Okay, I apologize to you guys. Internet went down, okay? But you should be back. We're back here. Okay? And I think I'm going to have to tell people just in case. Okay? Announcement, we're back. Anyway, we're going to see some numbers. People are coming back. Okay. So people are coming back. So what is this here again? Sigma. Sigma is what? Standard deviation. So it's going to be 12.8. Is that right? Okay, so, I mean, maybe we'll color it orange. Standard deviation, 12.8. Okay. Now, that's what this information tells us. And then what does it say? It says what? What percent of the population has a lifespan that is, what is question 1? At least what? 70. Yes. Well, they will. They're always going to give you the mean and standard deviation. When you give a normal distribution question, they're going to give it. Yep. Mm-hmm. And where does the mean go, ladies and gentlemen? Do you guys remember? Right in the middle. So what was the mean? 7.5 years. And again, the normal distribution is just saying you have a bell. Is that right? Okay, there's your bell. Now, this is not a picture of the question yet. At least 70. What does at least 70 mean again? X is what? 70 or more. So you put X is greater than or equal to 70. Okay? So where is 70 in relation to 77.5? Do you guys remember? To the left. Smaller numbers are to the left and larger numbers are to the right. Think of that real number line. So at least 70, this phrase here means what? 70 or what? More. So there's your arrow. So you're going to shade the portion of the bell that corresponds to 70 or more. And this now becomes, what was the game we played? Anybody remember the game we played yesterday? What percent of the bell is what? Shaded. So maybe I won't color it. I'll color it gold like in the question. This is a percent here. What percent of the bell is shaded? So you're going to use the TI. Remember that? But for the TI, you needed to know only 2 numbers. The lower value. What's the lower value? Lower is always on the left. Lower. And then what's the upper value? Yeah, you have to use the default because this goes on how again? It goes on forever. So the right value is green forever. If we can find it here, forever. What's the deal?
To infinity and beyond.
Okay, you guys okay? This is the forever part. So you just need to lower the upper values. You just need 2 numbers. Well, that's not true. What else do you really need? That's right. Good. You need the mean of 77.5 and the standard deviation of 12.8. So we're going to take all of that information here. Okay, we're going to go to the TI. Okay, so remember we go to second, distribution. What do we look for? Normal CDF number 2. Okay, and what was the lower value in this problem? 70, good. What was the upper value? 9,900 and what? 99. Okay, now it still has the mean from yesterday. We have to change it. What's it going to be? 77.5. What's the standard deviation? 12.8. You're going to do what? Paste it. So what is this going to be? 0.7 what? 1. Okay. Now, this is really, just so you guys know, and let's give you guys some detail here. What do they ask us for? They ask us for the percent. So we're going to have to give them a what? Percent. So move the decimal 2 spaces to the what? To the right. So the answer, and I'm going to use gold here, as a percentage, is what you guys see here. Wrong button again.
To infinity and beyond.
We need the applause. Yeah, I know. So if you said to me, Mr. Judge, what question do I give on a test? Give the percent, because they asked a percent question. Okay? Now let's note something, though. I'll say, what if they ask for probability? Yep. And the notation is the probability that x is what? Greater than or equal to 70? This is notation. That's going to equal 0.721. Okay, you guys okay with that? So this is if they ask for a probability, and this is if they ask for a percentage. So this is the work we did yesterday. Would you guys agree? Yep. And then remember, what was the key always from yesterday? What was the key? We said what? Always draw a picture of the what? Of the question. So for the question for number 2, it says no more than 80. How do we represent no more than 80? X less than or equal to what? 80. So this is the question for number 2. What was in the middle again? 77 point what? 5. No more than 80 here. So this is less than or equal to 80. So this will go all the way where? This goes to the left forever. Okay, so here you go. I guess since this is a percent question, we're going to shade this bow here. All right, you guys okay with that one? So as we look for the lower value, because again, we need 2 values, a lower and an upper. What's the lower going to be? Negative 9,999. Remember, those are the defaults. Lower. And then over here was going to be your what? Upper. Okay, so I say only 2 numbers because remember what you're going to do. Let's scroll out. Second distribution, normal CDF. The lower value is what? Remember, yeah. So I'm going to go down here. I'm going to put that. Don't put subtraction. You got to put that negative key. 9,999. And then the upper value is going to be what? 80. It's the same exact mean and standard deviation. So when you enter it for the first question, you have it for the rest. And your answer should be positive, ladies and gentlemen, just so you guys know. Okay, so what is this decimal answer? So I'm going to write it as a probability because you guys already know 0.577. So here's what this is a probability answer. Probability that x is less than or equal to 80. So now if they said, well, they asked me for percent, so you convert the probability to a percent. And that's 57.7 what? Percent. So isn't this kind of like what we did yesterday? Do you guys see what I'm saying? This is like what we did yesterday. Except we're going to have more. All righty. Let's do number 3 here. What was number 3 now? Do you guys remember? It's what? Less than 65. So, okay. Less than 65 years. So draw a picture of the question. The center is always the mean. And I guess for this question, 77.5. So less than 65 over here. So what does that mean, less than 65? It's less than 65, okay? So here you go. Here's 65. What's the deal? All the way to the what? To the left. Okay, so now what are you going to do? We need a lower value and an upper value. So we need the default because that goes on forever. Is that right? So what's the default again? Yeah, that's the lower default. And then this will be your what? Your upper. So we first are going to get the answer as a probability, and that will be approximate. So if you guys notice, you go, oh, is the statement here numbers less than, that's a probability? Yeah. The TI is going to give us a probability. Like up here, this was less than or equal to 80 and approximate. Okay, and then this will be, I think we did write it. Okay, yeah. Same thing. Approximate. So I'm going to give you all the gory detail with the notation. So now we could just use the TI. So in the TI now, remember the lower is the default and the upper is 65. So second distribution, normal CDF. Oh, the lower is already the default. Good. What's the upper? And then it's the same mean and same standard deviation. Is that right? Okay. So what do you get? Approximately what? 0.164. Good job. Okay. So here's the answer as a probability, but as a percent, what does that give you? 16.4%. And there it is. So let's go back and think a little bit about what this means. You guys know what it means? That 16.4% of the population live less than, to the age of less than 65, a lifespan that's under 65. Okay, 16.4%. No more than 80. Oh, about 57.7%. And then what is this? At least 70. What do we find for at least 70? About 72.1% of the population lives to an age that is at least 70 years of age. Yeah. Yeah. I mean, people care about lifespan. You know, lifespan's a pretty big deal. You know, my father passed away, unfortunately, very sad at the age of 59. Was he 59? 58, 59. Horrible. It's horrible, I'll tell you. But, you know, there's going to be people that say, but you know what, Mr. Judge? My father passed away at a younger age. Like, that's even horrible. That's even worse. And then some people live, like my buddy this weekend, his father passed away at 94. I'm mad, you know, at least he had 94 years. You know, it's a good one, 94. Yeah. And he had a lot of energy. 94. He's the kind of guy that would mow the neighbors' lawns. You know what I mean? He'd mow his lawn and the neighbors. Oof. Man was active. Good for him. I got to call the doctor. Did my medicine come in yet? You know what I mean? Can't even get my medicine in. All right, number 4, between 65 and 80. You guys know this question, right? Remember this one? That's the between 65 and 80. So number 4. So where is this between 65 and 80? In the middle, is that right? And again, it's a percent, so I'm going to shade this because I put the word percent. I'll just shade it, but it doesn't have to be shaded that way. You got a lower value. You have a what? Upper value, ladies and gentlemen, lower and upper. So this one's kind of like one of the easy ones, would you guys say? How do we know it's easy? Well, it's a between 60. There's no default. Yep. So the lower value here is 65, absolutely. And the upper value here is 80. Second distribution, normal. Lower is what? Lower is 65, and then the upper is what? 80. And I'm going to have to do that again because I didn't share that with you guys. Let's try it again. Let's clear it out. Second distribution, normal CDF. Okay, 65 is there for the lower. Upper is 80. And what do you get? 0.413. So let me write this down. Remember, between looks like this. This is 65 less than or equal to x less than or equal to 80. This is the notation for probability. And so the answer was approximately, what was that answer approximately? 0.413. Is that what that is? 413? Okay. And that's probability, but it's not percent. They ask percent. So what's the percent? Move the decimal 2 spaces to the right, and then you get what? 41.3%. There you go. So 41.3% of the population lives between 65 and 80. And that's the meaning of what you guys see there. Okay? Now, what I'm going to do here is this. I'm going to ask you guys, since we went over this question here ourselves, I'm going to say for you, I want you guys to try these questions here. Okay? So we're going to change, we're going to say, how about, what's the language we used? No more than, at least, less than, between. How about if I say, more than 80? Yeah, what's that? We got that. More than 80. 6. Between 45 and 60. And 7. Between 80 and 90. Okay? Yes.
What would be the difference between less than 65 years and no more than 65 years?
You got a very, very, very good question. And there's a very, very interesting and good answer. So you see this question here, less than 65. What if they said no more than 65? And then you say, Mr. Judge, I'm going to write that down. If they said no more than 65, that's X is less than or equal to 65. It's actually going to be the same picture. And you say, well, in one case you include 65 and in the other case you don't. Here's the answer. This is deep. You see that point I just put if you included the 65 kind of thing, right? Say, what if I have to include that? Remember I said to you guys yesterday, I showed you the formula, and I said you have to take like calculus, and you're finding really areas under the curve, and you can have to use a numerical technique, because the real technique to find area under curve is called using an integral. And then you're saying, I have to integrate. Well, yeah, you have to integrate. However, here's the deal. The area under a point, and that's what this is. When you include 65, the area under a point, any point, is 0. It's negligible. The reason it's negligible is because if you're going to find area under a curve, you really need what's called an interval. And under a point, you don't have an interval. So if you find area under a curve, this is all theoretical kind of stuff from calculus. You're finding this area under a curve here. Well, that's going to be a finite value. But the area under a point is 0. Because there's no dimension. There's no interval around that number. So that's actually the real answer, is that, area under points are negligible, 0. Because you need an actual interval to get an area. So that's the difference between no more than, where you include 65, and less than when you don't. I know. There's a lot of math under the hood here, ladies and gentlemen. There's a lot of ideas. The good news is you don't have to take Calculus 1 and 2 and then learn about integration and Simpson's rule. You guys get to do what? Use the TI calculator. Okay? Yeah. Well, you're going to see, we're going to transition. After these questions, we're going to transition to these kind of questions. That's what I call working backwards. And it is working backwards. But in all honesty, you have a nice function in TI that gives you the answer. Okay? But in the old days, even when we used tables, we'd work backwards with the tables. Yeah. So there's a lot of progress here, meaning you don't use the tables anymore. How we use the tables, somebody made them doing calculus, and we don't use the tables. It's all built in the TI now. And but yeah, you'll see when we work backwards with this. But that's coming next. So after you guys answer these questions, we'll take a break, and then we'll work backwards and answer the rest of those questions. Give you guys some time. Let's go back. Okay, more than 80 years. Okay, so here you go. $77.5 goes here. Okay. Where does 80 go? It's to the right. What is more than 80? Well, really, it's greater than 80, right? More than 80 is strictly greater than. So you say, oh, that's greater than 80. So, all right. So let's do this. We're going to shade the bow. So notice, isn't that a right tail? Okay, so I'm going to use notation because the TI is going to give us this answer. But what do you guys notice, though? You need a lower and an upper value. You have a lower. The lower is here. Is that right? Here's your lower. And then your upper is by a default. Isn't it a default? There's my upper. Yep, sorry. Lower and what? Upper. Okay, so notice this is how we represent more than 80. And now we just punch this in the TI. So 80 and then 9,999. Second distribution. Binomial CDF. Oops, what did I do? I think I hit the wrong one. Sorry. So second distribution, it's number 2, normal. What's the lower value? 80. What's the upper? 9,999. Okay, and the mean again was, or is, 77.5. What was our standard deviation? 12.8. No, it was a mistake. This is the normal distribution. So it's normal. Right? Normal CDF. Yep. So here we go. It's going to be what? 0.42, what is that? 3. And then move the decimal. What does it give you? 42.3%. So what that means is 42.3% of the population lives to more than what? 80 years. Okay, pretty good. 42.3% of the population. All right, here we go. $77 point what? 5. And this is like between 45 and 60, right? Isn't both 45 and 60 less than 77.5? Bless you. So this is between here. Mm-hmm. Yeah, like these are kind of the nice, you say, these are kind of the nice, simple questions. You go, what do you mean nice and simple? Well, They're actually, the between questions give you the what? The lower and the upper. It's these other questions that don't, and then you have to use a default. So that's why it's kind of like you go, oh, wow, that's not, So it's a process, like I said, it's reading and process and following the instructions, normal, CDF, and so that lower value is what? 45, and what's the upper value? 60. It's the same mean, same standard deviation. And there you go. What do you get? Yep. 0.08 what? 0. %. Okay, so 8% of the bell is shaded. What that means, 8% of the population lives between 45 and 60 years of age. Lifespan. All right. And then between 80 and 90. So isn't 80 to the right? Isn't it larger? So is 90, right? So between 80 and 90. Okay, so you say, how do we write that? We write it this way, between 80 and 90. 80, last one, go to 90. Okay. Lower here, and then what? Upper. Second distribution, binomial CDF. Lower value is what? 80. Upper value is 90. Same mean and standard deviation. So as a decimal, this is a probability value. It's going to be what? 0.25. What is that? 8? Okay. And as a decimal, that's now what? 25.8%. So that's kind of interesting that 25.8% of the population, what do they live between? 80 and 90 years of age in Hawaii. What do you guys think? When are you moving? Next year? When are you guys moving to Hawaii? Anybody want to move to Hawaii? Too hot in Hawaii? It's like San Diego. Average temperature like in Honolulu is something like 72 degrees or something. Huh? It's what? Huh? Well, yeah, I guess well, it's not that they don't want mainlanders. I think there's some truth to that. It's the attitude they don't want, I think, partly. That's partly it. You'll be tolerated. I think you'll be tolerated if you have a different attitude. Well, and I think too, there is some truth to the idea that the islands were stolen, and there's some resentment there. And yeah, I mean, but that's kind of like a historical thing. I hate to say it, There's a history. Yeah, I mean, it's a common story everywhere you go. I mean, even right now, we're seeing that in Ukraine. Russia's going, we want that land, and this is ours. Yeah. So it's a common. The sad thing is it's common, or it's part of history. But yeah, I mean, I think for Hawaii though, yeah, and I think even depending on the island, I mean, I think all the islands have some of that, but some are worse than others. I hear some are worse. Yeah, I'm trying to remember. Is it Maui or Kauai? Can't remember. Anybody been to Hawaii? What do you think? If you really thought about it, right? Would you live there? Well, on the Big Island, Well, Maui's pretty big too, though. But yeah, I can see that. Anybody? Let's see. Who are the people that have been to Hawaii? Would you move there? No. Why? Why not? Just curious. Right. Would you move? That's right. Mm. Hmm. Hmm. I mean, I don't know. Mm. I I think it's a catch-22. I think certainly, they rely on tourism, but you have to rely on tourism. So I think, you know, yeah, yeah. But I know, for example, I know people work. They work, so you need to work. Um, you know, I don't know. I mean, I can two things. What to say? I wouldn't mind living there personally. I can find a way, but I think you might get tired of living there. And people who do live there, who will move there, they get what's called island fever. They got to get off the island for a little bit. So they get off for a little bit and then they get back on. So it's kind of ironic that some of the people, like there's a lot of people who leave the islands and, it's hard to live there. It's really a hard lifestyle, but it's a beautiful place to be, great weather. I remember in Kauai, for example, driving by, what's the Facebook guy? Mark Zuckerberg? Yeah, the guy who owns Facebook. Evidently, he bought some land out there. It was a whole big deal. They didn't want to sell it to him, but he finally won somehow, and I don't remember all the details. And some of the locals were telling us, but he bought some land in Kauai, and it's kind of known as Billionaires Island now, because a lot of billionaires are going. But what they remarked, what was interesting, is he actually was building a water tank, like a huge water tank on his property. Like huge, like absurdly huge. And they're going, why does the guy need all that water? He only has a family of like 3 or 4 or something. Whatever. Why do you need all that water? It's like a weird thing. I don't know. It almost sounded apocalyptic, kind of. You know what I mean? They almost presented it as if, like, does he know something we don't know? Yeah. No, it was just a huge tank he was building. Like, it was enough for a city. Like, why does a guy with only two adults and 2 children need that capacity of water? They were kind of suspicious about it. But it did sound weird. We did drive by, that they took us by, and we're like, wow, we're watching him build his place, Mark Zuckerberg. But yeah, it's kind of known as Billionaires Island, but and I think it's a great place to visit, but it might not be the best place to live. Great place to visit, but living might be a whole other story, but I don't know. Well, yeah. Yeah. I mean, that's another thing. How many people I like the mountains. I love the mountains. But I don't know if I'd want to live there in the winter. Oh, yeah. 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 Yeah, I actually seen some of the protests, ironically. The protests was really for what was going on in the main island, but in Kauai they were protesting it. I remember driving by and like, whoa. Yeah, and I don't remember the details, but I remember like, oh yeah, okay. It's kind of the same, the same old story of things, unfortunately. But yeah, a great place to visit. But and I would love to live there, but it may not be the best place to live. I don't know. Well, a lot of people, that's what they do. They don't live there a long time. Yeah, that's the kind of thing. If you can afford those things, like in the mountains, you might say, oh, you might have an Airbnb in the wintertime, you rent out. But you may want to live there in the summer or something, or fall and spring. I don't know. Yeah. Being cold. You guys ever been cold? Yes. Snow, cold, and then you ever slip on the snow and the ice? Horrible. Oh, you're on the floor before you even know you're falling. You fall fast, not slow. You're like, what just happened? But it's over. You're on the floor. Like, what? Yeah, I don't know. There's a lot of things about LA that are good in terms of weather and, it's not the best place to live in terms of to afford to live here, but you got weather, you got things to do. I don't know. Yeah, food is good in LA. A lot of big cities is good, like even New York. If you could live in New York, you got some of the best food ever. Anyway, let's give you guys a break, okay? And we'll work backwards. And anyway, because it's all interesting ideas, so we'll give you a break. What's that? Okay, ladies and gentlemen, let's take a look here. We're back, and what we're going to do now, let me take a look at this for you. Let me demonstrate to you another worksheet. We're working backwards. So here we go. This is working backwards. Okay, so we're going to put that here, working backwards. I'm going to start again with this IQ score, but working backwards. Now, remember we asked you guys this question before. And actually, let me do this. Let me see if I can... I got to download it myself. Okay, so I'm going to have to... I have to download this worksheet myself. We're going to work backwards, so... let me do this here. I'll download the sheet and, okay. So I'm going to go to my own website, download the working backwards with the normal distribution. We just have to learn a few concepts and ideas about how to work backwards. And you're going to see it to be easy. So, okay, let's go to... Let's go to my website, www.ddjudge. Okay. Okay. All right, so I'm getting this sheet here, and I'm going to enter this in Notability. There it is. So we have it here now. Okay. Wrong button again. So let me get in that screen. We don't want that creepy laugh. You guys don't like that creepy laugh, do you? Does it scare you? Ah, okay. We want the applause. There we go. Now, remember this. We started this discussion about, or the first examples we work with were about IQ scores. Is that right? Now, here's what's going to happen. We're going to work backwards. This is what I mean by working backwards. Remember this? What IQ scores are normally distributed with a mean of 100 and a standard deviation? What IQ score is needed to be considered a genius? Okay, so remember, IQ scores are normally distributed bowl-shaped curve. The mean is what? 100, and the standard deviation is 15. So, if you want to write down some details, we know that X equals an IQ score. They're telling us mu is 100 and sigma is 15. So here's going to be a setting we already work with, okay? All right, you guys okay with that? So far, so good? All right, so we already we've already set this table with these questions here. Now, remember, the mean is in the center here of our bow, like always. Now they're saying, what IQ score do you need to be considered a genius? A genius, by definition, what did we say yesterday? You're in the top what? 400, okay? Or top 4%. to be considered a genius, you're in the top 4%. So they want to know what IQ score. In other words, they're trying to find this value of X. Okay, that threshold value. And this is different now. Before, they gave you all these X values, right? X is between, 120, 135. X is no more than 120. X is at least, 80, all that stuff. Now they're saying to you, hey, what is X? And that's what they're saying. So the definition of of somebody who's a genius, you're just in the top 4%. So the question is, what is the value of X that corresponds to this, to be in the top 4%? Okay? That's really what's going on here. So, of course, in the past, there was a lot of information. And actually, this is a different question, but there was a lot of information. Oh, yeah, here was it. We were going to even ask you eventually, what IQ score do you need to be a Mensa member? That definition is in the top 2%. Okay, remember we gave you that yesterday? And then remember we even mentioned this? This is a term that's no longer used, being feeble-minded. Or, like some of these terms aren't used anymore, but they're in this worksheet that I sent you guys. I think they're in this here, IQ score information and classifications here, okay? So you say, boy, Mr. Judge, is that you? And I say, no, it ain't me. This comes from other disciplines. This is might even be psychology discipline. Feeble-minded. They might even talk about that. I don't know. I haven't majored in psychology, and I don't know what they really talk about. But this stuff comes from them. So bottom, maybe I think I found this. It might be legitimate feeble-minded bottom now, 2%. They want to know again here, what's the X value? Okay, to be separate the feeble-minded people from the rest. Like here, to be in Mensa. That was a good thing. You guys remember? You're in the top what? Top 2% to be a Mensa member. They want to know what's the value of X. Okay? So all of these kind of ideas are coming to us. We're going to find them. And it's going to be really simple, in all honesty, if you guys want to know the truth. Again, we don't need to know what about these Z values, like some of you guys may have had to use in the past, right? We don't need to know how to work backwards with some of these things here. And this is what the notes I had working backwards back in the day. If you ever get time, I'll kind of edit this. But we're going to kind of find a lot of these things with the TI. So we're going to skip over that, and we're going to say to you, well, how do we do things with the TI? Well, let me express to you guys this. We're going to learn about something called the inverse what? Norm key, inverse norm. That's working backwards. Okay? And so for my first question here, inverse norm, I'm going to share with you guys how this works. Just on this worksheet here, we're going to find the genius, inverse norm. So you say, okay, in the TI, let's put our notes. Working backwards is the inverse norm function. That's what you want to be aware of. Okay? Now, you also want to recall you got the mean and the standard deviation for a normal distribution. Okay? And so the question here is, what value of X do we need to be in the top what? Top 4%. You guys okay with that? Okay. So focus on the TI. Let's say, okay, TI, we're going to clear the rest of this. We're going to work with you. We're going to work with working backwards. Second distribution, what do we look for? Inverse norm. What number is inverse norm? You guys see it? It's number 3. Okay? Inverse norm. Now, you see that first thing? What do you think that means? They say area. Is that right? Area. Okay. So if I go back to my picture here, top 4%, we're going to use this TI here, and I'm going to say this to you guys. They're saying, first of all, this is a right tail. And this measures what? 4%. It's in the right tail, okay? Top 4%, that's 4% of the area in the tail. How do you write 4% as a decimal? 0.05. So I want you guys to notice two things. 4% is 0.04, and they're referring to the right tail because it's top 4%. So far, so good? So you say, well, what do I enter in that TI? Well, you enter the area for the right tail being 0.04. You enter that being 4%, okay? And then what do you go down to? What is mu? 100. What's sigma? 15. Well, what is 4% again? Is it the left tail? Is it the center? Or is it the right tail? Right tail. And that's all you need, ladies and gentlemen. You say, that's all I need? Yes. Communicate the tail of being 4%. And what do you think you get as an answer? Approximate to the whole number. Okay? Because these test scores are to the whole number, meaning the 6 is your whole number, the digit to the right's a 2. So what's the answer? 120 what? 6. You guys okay with that? I know your question already. It's going to come up. Just be a little patient. I'm going to answer your question. I know you have the same question. Oh, you don't? Okay. That was the question. I already know. That's the question. See, Mr. Judge, he is psychic? Not really. From experience, he knows, but he has to give. Those of you guys that have the TI-84 plus CE, you have the option for left tail, center, and right tail. Okay, you guys know what I'm saying? So let me say that again. Did you have that option on your calculator for the left, center, and right? So some people have the option. Anybody else have the option for left, center, and right? Yes. Now, to let you guys know something here, some of you guys don't have that option. And I'm going to change the TI to show you. In other words, if I go back to the TI, right, and you go, Mr. Judge, my calculator, I have the TI-84 plus, or maybe even TI-83. Okay? You go, what do I do here? I followed your instructions. Let me scroll out. Second distribution, inverse norm number 3, and I just have area, and I have the mean standard deviation. You don't have the option. All right. Okay. So here's what you guys do. And I'm going to go back here. The default, there is a default. When you don't have that option, this is what some of you guys are going to have to use. You see this portion of the bell on the left? To the left of what? The X value. Could you tell me if the top 4% is in that right tail, what's the complement of that? Good, 96. So in other words, this portion is 96%. Okay, you guys okay with that? It's to the left of the value. Say that again. The complement of 4%, isn't that 96%? And don't you write 96 as 0.96? You see what I'm saying? Okay. And this is the area that is to the what? Left of that value of X. This is called the what? The default. Yeah, the area to the left of the value. It's always the area to the left. So the default is always, always, always area to the what? Left. So now put what? 0.96. Put your mean of what? 100. Standard deviation of what? 15. paste that in. What do you guys get? You get the exact same what? Answer. Okay, so some of you guys are going to be in the default mode because you don't have that option. Always remember, it's to the left, your left of that value. Now, if they say top 4%, what that means is the complement is 96%. That's the area that is to the left of this X value. So you say, to the left of what? Remember? This value of X, the area to the left is 96. Yes. Yeah. So those of you guys that don't have the option, you always have to use the default. And so now go over to the next question here. And you go, what's the next question? Notice this. If your IQ score is 126 or above, this is what they mean. You're in the top 4%, and you're considered a genius, ladies and gentlemen. Okay? So even if your IQ is 130, you're a genius. 135, you're a genius. But what they want to know here is this. To be a Mensa member, remember this? You got to be in the top what? 2% of IQ scores. So how do you write, again, this is a right tail. How do you write 2%? How do you write 2%? I'm going to go to the fancy calculator, and I'll do it both though. Second distribution inverse what? Norm. You guys okay? This is now the inverse norm. How do you write 2%? 0.2. Isn't that the same mean, the same standard deviation? Isn't this 2% in the right tail? You with me on that? 2% in what tail? The right tail, because it's the top 2%. If you hit enter, what IQ score do you need now? Go to the nearest whole number, 131. So to be considered a Mensa member, you need an IQ score that's right in here. It has to be at least 131. So yes, you're a genius, but you want to know something? You're what? You could belong to Mensa and go to the parties, Mensa parties, do Mensa things, whatever they are, and hang out with other Mensa people. And they hang out, they get together. I bet you if you're into social media, you might look on Facebook and find what? Mensa people. I wonder what they write down. Maybe you want to try to join the Mensa. Maybe they say they actually have a card. They walk around with a card, by the way. You get a card as proof. Anybody here a Mensa member? They're everywhere. 2% of the population. Anybody, like, for example, elementary school, what was the class size? Class size in elementary school, do you guys know? What's 2% of 25? 0.5. So you had a half a Mensa person. Okay, maybe you needed 2 classes. 50 students. 2% of what? Times 50. You know what that means? There was somebody who had an IQ that was what? One person had an IQ that was above. Because Mensa is in the top 2%. We just found it. It's right here. You have an IQ that's what? No, top 2% was 131. And you guys can look up online who are some very famous people who were Mensa members. They kind of like to brag. At least the famous people brag. You know, There's some famous actors and actresses that are Mensa, and they go, "Oh yeah, I'm a Mensa." Okay, whatever. I'm not so sure. But what's the key? Inverse norm. Okay. Now I'm going to ask you guys here. Okay. I want you guys to note something. We can find the IQ to be in the top 1%. Now, what do you think top means? Like before with the box plot. Remember I gave you guys that language? One of the reasons I gave you guys that language is because of what we're doing here. You want an IQ score to be in the top what? 1%. 1% is 0.0 what? 1. Okay, you guys okay with that? 1%. Now, there's not a name. There is no group, but you can find this. Okay, so there isn't really a name. You guys know what I'm saying? There's only the top 2%, top 4%. They give names, but we can find the IQ that represents the top 1%. Just change that value. Now you say, okay, second, distribution, inverse norm. We're going to change that first area to point what? 0, 1. Paste it. 130 what? 5. Is that right? So that's the IQ score you need. That's the value of X. X is what? 135. And it's really 135 or more. So, anybody that has an IQ score of 135 or more, you're in the top what? 1%. And so these kind of questions you're going to see over and over again. You're going to see, not just top 1%. This is, again, I won't do the bottom there. I might go out here. Okay, let's go to here. Let's go do the IQ scores. I think we're still working with them. Where is it? Where is it? No. Here we go. What about very common? Or let me do this first. Let me backtrack. I apologize. What if you're a person who says, you did not show me, Mr. Judge, the default? You guys know what I mean? Some of you guys don't have the fancy calculators. What do you have to do if you don't have the fancy calculators, the default? Area to the left of this value. What's the complement of 1%? Good. This is the default. You guys remember? So if you are one of those students, let's verify. Area to the left is 99%. Second distribution, inverse norm, point what? 99. Change that. What is this? Is it 135? So the default, you guys see, is the same. 135. So if you guys have that default, you can simply use the area to the left. Okay? Let's look at the question here. 2%. Now this is going to be what? 98%. And you write that as point what? 0.98. Right? Area to the left of that value, I bet you it's going to be 131. You guys want to see the default again? So we say second distribution, inverse norm, 0.98, same mean and standard deviation. Isn't that to the nearest whole number 131? So for some of you guys, you have the default. So what I wanted to do is say, what if it was the top? Here's some very popular. top 5% of IQ scores. You know what else is popular? Top 10%. So we can find the top 5% of IQ scores and the top 10%. $100. Here's the X value. This is going to be what? 5%. How do you write 5%? What do you do? Should we do the default or we should do the fancy dancy calculator? Let's do fancy dancy. Okay. Second distribution. Inverse norm is number 3. Is that right? So what do I use again? 5%. This is there. It's the right tail, isn't it? This isn't the default. What IQ score is that? 125. X will be what? 125. This is your IQ score. Okay. If you don't have a fancy calculator and you had to do area to the left, what's the area to the left? What's the complement of 5%? You guys see how that language is creeping into your vocabulary? Complement, you know? All right, let's try that out, right? Let's do the default, because some of you guys have that default. Second distribution, inverse norm, at 0.95. Uh-oh. What is that to the nearest whole number? That's what we had before, 125. Top 10%. So what do we do? Let's go fancy dancy. Second distribution, inverse what? Norm. You guys know what 10% is? Isn't that 0.1? Isn't that still, it's the top, so it's area to the right. Top is on the right, is that right? So what IQ score represents that to the nearest whole number? Yes, 100 and what? 19. So you can actually say, oh, I know, X equals 119. Same thing. So anybody that has an IQ score, you know, that's at least 119, you say they're in the top 10% of IQ scores. Now let's see if you're awake. This is a question that people have been waiting for. What does this mean? What's Q3? Yeah. Q3 is what? The 75th percentile. Is that true? So sometimes they'll say, hey, what value represents the third quartile value? So you might say, okay, what's happening here? Well, isn't there a value of x between, right? You see this 25, 25, 25. Isn't this 50% over here? But in fact, ladies and gentlemen, let me do this even better. Since we're on the topic, right? This is where your first quartile value will be. And this is where the what? Third quartile. This is the second quartile. So if you partition the area into 25%, when they ask you about the third quartile, that's very easy. They're asking you about what? This number. How do you think you're going to begin to answer that? How would you begin to answer this kind of question? We've been going over what? Top, the other sheet, top. So what would this be? Is it 75? What do we think? This is 25. Yes, this will be the top 25%. Yes, outstanding. So you would say, I can still consider the right tail like we did. Every one of these tops is a right tail. Is that true? So this percent is 25. So how do you write that as a decimal? This is point what? 0.25. So in the TI, what would you do here? Second distribution, inverse norm. This is 0.25, okay? This is area to the right. Paste that, and what do you get? Right, to the nearest whole number, what is that? Is that 110? Okay, now let me do something here too with this calculator. I can say this. Second distribution, inverse norm. What if I want to use the left, like the default? Say, give me the left now, like the default, okay? What area should that be? That should be what now? 75%. Is that true? So you say, well, why is that 75%? Even if I did the default? Well, because the complement of that 25% would be what? This whole thing is 75%. And as a decimal, it's 0.75. So that's even true of the default. So your fancy calculator gives you area to the left, area to the right, okay? Paste it. Notice you're getting the same answer there. Do you know the definition of P75? 75% of the data is behind it, but 25 is in front of it. If it was the older calculator, second distribution, inverse norm, you said, do I use that 75% area to the left? Sure. What do you think you got? Same thing, 110. Okay, you guys okay with that? So remember, the definition of the third quartile is the 75th percentile. So you're drawing this picture here by definition. 25, 25, and 25 gives you that what? 75. But the top, then, this is now top 25%. So let's see if you're awake on this one. Right? This is another note. What's the definition of D6? What is that? That's the sixth decile. That's correct. 60th percentile. Yes. There we go. So if you recall, what did we just say here? This is Q2, 100, in the middle, the mean of that bell, 100. Remember that? So what is Q2? Isn't that the 50th percentile by definition? Isn't that P50? So far, so good. So where would P60 be? If this is P50, half the data is to the left of 100. That's the center. That's the mean, right? 50% of the data is to the left of that number. Remember we seen that yesterday? This is P50. Where would P60 be? To the right or is it to the left? Good. Now this is not to scale, so P60 would be here. But let's see if you're awake. Do you know your definition? What percent goes right in here? Do you guys know? Want to take a guess? I'll say this is 10%. But if we're going to use the right tail again, what percent of the bell would be in this right tail? This is a right tail scenario. Good job. That's 40%. 40% being point what for? Okay, you guys okay with that? 40%. So what do we put here? Second distribution, inverse norm. This is now 40%. You guys okay with that? Now this is area to the what again? Area to the right. What's that value? Anybody know? What's the whole number? 104. So this is kind of what, people sometimes they have those questions. You go, boy, Mr. Judge, they want to know the D6 value in this distribution. They may even know, they want to ask you this question. What's D9? What's the definition? P90. Okay. A 100 goes here. If this is P90, remember this is also P50. P90 is where? It's to the right. Is that true? And 90% of the values are below this number. But what does it mean in terms of the right tail? 10%. It's the top what? That's the same as the top 10%. And you already did that question. So top 10% in the TI this is your top 10%. This is 100 and what? 19. Okay, this is top. Now you might say, hey, Mr. Judge, what about questions like this? The bottom 10%, the bottom 5%, and even the bottom 1%. 100 goes here. So what do you think bottom 10% would be? Bottom 10%, this is now going to be a what? It's a left tail now, okay? That's what they mean by the bottom what? 10%. Okay, so that's kind of what they're talking about. What IQ score would go right in here? Fancy dancy people. Second distribution. You use inverse norm. Remember that? Inverse norm? And it's already on 10%. But what kind of tail is this? It's not a right tail. It's a what? It's a left tail. Say, it is? Yeah, that's a what? This is a left tail because you're talking bottom 10%. So in the TI, you hit that left. And what do you get? What's your value? 81. Okay, you guys okay with that? Compare that to, and what if you said, but Mr. Judge, what if I have the default? Right? Remember all you default people? All the default. You go, well, what would I do? I have this calculator. I'll say, okay, go to the second, go to distribution, go to inverse norm. The area you're going to say is 10% still, but your default was always to the left. Is that true? So in that case, it's still what? What we got. Because it's area to the left of that value. You say area to the left of what value? This value. Still 81. Yes. Say that again. Mm-hmm. Yeah. And do you have the default or do you have the other one? Okay, then take a look at this one. I'm going to change the color. You go, but Mr. Judge, what if it's bottom 5% now? Right? Not bottom 10. This is now, it's still a left tail. You guys agree? But now the area in the left tail is what? 5%. Okay, that's the bottom. So if it's ever bottom, it's area to the left. It's the left tail. So you just have to know how to represent 5%. How do you represent 5%? There's your 5%. So you say, well, I'm going to stick with the default. Okay, well, it's always area to the left, second distribution, inverse norm, and it's now going to be 0.0 what? 5. All right, so what number is this? The whole number, because these are IQ scores. 75. And it's not 75%, it's just that the score is 75. Like here, your score would have to be 81. Okay, this is the value of X we put down here. Value of X we put here. So you guys can compare and contrast. Whenever they use the phrase bottom, that's really left what? Left tails. And even if you didn't have the default, what if you guys had the fancy version, right? Second distribution. I'm gonna change this to the fancy version. Second distribution, inverse what norm? 5%. You're now going where? It's already just on the left. That's a bottom. Oh, what happened? Let's have to do it again. Second distribution, inverse norm. We're doing the 5%. Mean is 100. Standard deviation's 15. This is the IQ. Now, it's already on left tail. So notice we still get what? 75 because it's already on the left tail here. So left tail is, you associate bottom with the left tail. Top with the what? Right tail. You just got to know your left and your right. You're looking at your paper. Do you know your left? Do you know your right? You guys see what I'm saying? What about this one? Bottom 1% of IQ scores. In orange. Here's your X value. This is now going to be what? 1%. Okay. And how do you represent 1%? 0.01. Again, a left tail. This is the bottom. So I might just have to write that down, left tail here. So let's do that here. Second distribution, inverse norm will be what? 0.01, and it's area to the left. What's this number to the nearest whole number? This is what? So the IQ score is 65. There you go. Bottom, what? Bottom. And remember, this is the questions that sometimes people ask. They don't understand. They go, but Mr. Judge, what if they ask me the value that represents the first quartile? This is for IQ scores. This is now P what? 25 or the first quartile, because isn't that the definition? Right, so what goes down here? 25%, 25%. You guys remember? I would say focus on the what now? Focus on, what is that right tail? Sorry, not right tail. This is a what? Yeah, left tail. What would you say? This is the bottom what now? The bottom what? 25%? Isn't 25% right here? Right? 25, 25, and so on. And how do you write that 25%? This is going to be point what? Is that 0.25? So what's this? Second distribution, inverse norm. Point what? 25. This is area to the left. That's the bottom. Is that right? So what is this number going to be? 90. This is 90. What's the name of this key? Inverse norm. Do you guys want to know what inverse kind of means? Like reverse, inverse, or backwards? That's what I call working backwards, because they give you now the percent of the bow that's shaded, and you got to get the X value. Forward is they give you the X values, but they do not give you the percent of the bow. That's what you're finding. You're working backwards. Okay, you guys okay with that? Let's see if you're really awake. D what? What's D4? Thank you. P40. That's the definition. $100. Isn't this P50? Where'd P40 be? To the left. So let's see if you're really awake here. What percent of the bow then would this be as a left tail then for P40? Remember the definition of P40? What's that definition? Anybody know? What percent is here? This is the bottom P40. The bottom what? 40%. 40% of the data is what? 40% is behind that value. Remember this? And how do you write 40% as a decimal? 0.40. Well, that's 40% of the bow. You're going to need to look for, again, you're going to have to use the inverse norm key now, because this now becomes the bottom what? This is the bottom 40%. So they're asking you, hey, what number represents that bottom 40% for IQ scores? So that, again, in the TI, you go to what? What's this key again? Inverse norm. Okay, is it now 40% is 0.4, right? And then is it still a left tail? Good, because it's a bottom. So what IQ score is that? 96. Yeah, actually, that's exactly what that is. P40 is the IQ score of 96. So this is really what you're answering here. Well, 40. The definition, remember, for percentile, like PK, I think, remember, we gave you this definition. We said, okay, definition of PK, that was the kth what? Percentile. Okay. So if they gave you, for example, like P40, that means 40% of the data is behind that number. So 40% of the data is behind the number 96. The IQ score 96. So you're actually partitioning your bow here, okay, into that top and bottom here. Yes. Well, on the default, remember the default, right? This is a left tail. Is that true? Let's mark this down, right? So this is a left tail. So you say, remember, what does the default always do? If we go to that default, it's always area to the what? To the left. So we go to inverse norm. They're not even going to give us, you got to put the 40%. They're not even going to give us the option for left, right, or even center. So you still get the 90 what? The 96 like we got before. So that's because the default is left, and we're choosing left for bottom in this, the fancy dancy, we choose left. So in the fancy dancy calculators, we made that choice. Yes. I'd have to look it up, but let me try to do something here. Look at center. I'm really not how am I gonna put this? I really do everything the old-fashioned way, and I've just learned how to do it with the TI2. So the center, let's try to do center. Let's try to figure something out. See, let's go to the fancy dancy. Let's try center. What if we did the center? I think if I'm thinking of it correct, we should get two numbers. Second, distribution, inverse. No, we should get two values. Like if I said, oh, the center, just center 40. Let's go to the center now. Okay, this is center 40. You guys agree? Oh, I'm sorry. Second, distribution. I go, wait a minute, that's the same thing. Let's go over now to center. Oh, I didn't hit enter. I think you should get two numbers. Yeah. Okay, that was center 40%. You guys see what I'm saying? Center 40%, let me see. Let me show you guys. It's like, remember center 40? This is the center 40 if you guys want to know. It's not top or bottom language, but this 20%, 20%. You guys see what I'm saying? Center 40. You go, what did it give me? Two numbers? Because this is, again, this is in the center. 20 plus 20 does give you 40. So what it would do then with those two numbers, looks like that'll be 92. And what's the other one? 108. 108, 92. So this is what I'm interpreting that as, these two. But they never ask you these kind of questions working backwards. They don't ask you for the center. They only ask you for top and bottom. So you only need left and right, because top is to the right, right tail. Bottom is a left tail. They don't really ask for center at all. What's that? No, I've never put the center question. I've only put tops and bottoms, you know. And typically the standard is top 5%, you know, there's a 1, 5, and 10. Top 1%, 5%, 10%, bottom 1%, 5%, 10%. That's the standard. But what happens here is with, I would say, I guess we're doing that. What happens here is because of the IQs, they're not nice like 1 and 5 and 10. They're like 2 and 4. So, but that's, again, that's the discipline of psychology, because they actually measure IQ scores. This is their thing, IQ scores in psychology. They're always going to give you that. You know, in real life, you say, what would I do in real life? Well, in real life, of course, you gather data. You look at the histogram. You go, most of the data is in the what? Center. You compute the mean. You compute the standard deviation. You now can give information based on knowing it's a normal distribution, you know, and this process. And there's a lot of things that are, you know, that work with a normal distribution. Anything that grows natural or is manufactured, anything's duplicated over and over again, because nothing is created the same way twice. Nothing. Not even people. God doesn't even bother. He goes, you know, I'm going to make everybody unique. So everybody's different. You know, snowflakes are different. They're going to give it to you. Yeah, they're going to give you those mean and standard deviations for normal distribution. Like, you guys remember, what did we work on earlier today? Remember lifespans? Okay. So they're going to change the question on you. They're going to change the question. What lifespan, okay, represents the question 1, top 5%. Question 2, top 1%. Question 3, bottom 10%. Question 4, the bottom 5%. So these are all the kind of questions we just went over. They're all using what key again? Inverse norm. So it's almost like the function of the day is inverse what? Inverse norm. Do you see what I mean? So give you guys some time to try this out, and let's see how this goes, okay? All right, let's try this out. You guys ready? All right, let me move things around. Top 5. What's the mean again? Remember, this is lifespan now, right? Yeah, so in the center, you're going to put what? 77.5. Okay. Top what? 5%. So you're going to have to try to find that value of x. Don't forget, you have to have the mean and the standard deviation. Now, isn't this a right tail? So it's a right tail. So if we go now to the TI, clear. Second distribution, inverse norm. 0.5 is 5%. Is that right? And the mean is going to be what? 77.5. What's the standard deviation? 12.8. Okay, now is this a right tail or a left tail? Okay, then hit right. Okay, so there we go. Now, what do we get here? What does this mean? Do you guys know? What are we looking at? Go to the nearest whole number. Yeah, this is 99 what? 99 years of age. So if you live to at least 99, what that means is that X value is 99. If you live to at least 99, you're in the top what? 5% of ages. Maybe you want to call that group what? What do you guys want to call those people? Old timers? I don't know what you want to call them. Golden, I don't know. Golden age or something. That's pretty good to be in the top 5%. 99. Wow. Did you guys see what we're saying? Questions? Yes.
I have 3 family members over 100.
It means you got some good genes. Good genes. My grandparents lived to be in their like 94, and 92, I think, or 93. But here's something that might be interesting to you guys. What's their lifestyle?
Well, they live in El Rancho.
And what do they eat?
Whatever they have there.
Okay. Yeah, here's what I'm getting at. The thing about it is, here's what I'm kind of getting at. That I remember years ago, there was a survey that came out, and they even talk about different ethnic groups on who, it's not just what state and the lifespan, average lifespan is. Even amongst ethnic groups, you have an average lifespan. And some data came out, like it must have been 6 or 7 years ago, maybe longer, maybe even 8 years. And I remember hearing it on the radio about which new data came in, blah, 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 blah. Which ethnic group you think had the longest lifespan in the U.S.? Huh? You guys know? Well, we're talking in the U.S. Hispanic people, right? And I remember my class was like, yay, yay, up and down. Like, oh, yeah. And of course, I had to burst people's bubble, right? It's the same kind of questions I ask people now. And I'm talking about my relatives on the Hispanic side lived that long. But if you ask and you look into it, you say, well, what was their lifestyle? What were they eating? What are they eating? Whole foods. They're eating eggs. They're eating cactus. They're eating beans. They're not eating out. You guys know what I mean? They're not going to the Hat and getting the chili cheese fries with pastrami on top. You guys know what I mean? They're not doing that. They're eating nice whole foods. And more than that, what are they doing all day long? They're not necessarily, they're running around. My grandmother was doing laundry. She never sat down. My grandfather, he came home from work. You know how he relaxed? Pulling weeds in the yard. You guys know what I mean? Outside in the sun, pulling weeds. In the heat. Who does that? Not me. Not me. You used to watch my grandfather like, guy was outside pulling weeds to relax and eating whole foods when he came inside. So, he lives to be like 93, 94. So if you ever really pay attention to the little details like that, and that's why I always ask the question, they're living to 100, I guarantee you, they're moving around and they're eating right. You know what I mean? They're doing things right. They probably aren't even drinking. Yeah, they do. They'll do things like drink tea. You know what I mean? Yeah, right. They'll drink whatever tea. You ever hear that these herbs every morning, and it's like, are you kidding me? And so I had to tell my students, okay, remember, in order to gather that data, you have to die. They got to get your age, right? And it makes people think. They go, oh yeah, what's for lunch? Chili cheese fries at the Hat with pastrami on top with a side of ranch dressing. I know. Sounds wonderful, doesn't it? What's that saying? Some. You guys probably know this. What is it? You plan on living a what? Oh, I'm gonna mess it all up now. I don't even remember. Living a long time. You're not living a long time. You're having a good time, not a long time. You're trying to have a good time, not a long time. I think that's us. I think that's us. I think that's a lot of us. But if you check like with your grandparents, maybe, or even older, they're living differently. They're eating differently. They're doing everything differently. So it's kind of, yeah, exactly. Sorry to burst people's bubbles, but I don't know. Is diesel better than gas? Yeah. Yeah. Yeah, I know. It's look. My mom, she died of diabetes, and at the time I was kind of upset with her, but now I understand a lot better. But she would eat. What she if they would bake chicken, she wouldn't eat the chicken. She'd eat the skin off everybody's plate. This chicken, you bake it instead of eating healthy people will remove the skin, they eat the chicken. She did the reverse. I'll eat all your skin. That was my mother, Oh my God. You know what I mean? Gosh. I do, but I don't usually eat it, But people used to do that. They would bake it, the whole thing, and barbecue it, Yeah. Yeah, isn't it like fried? They deep fry it? Yeah. Yeah. Exactly. Chicken skin and probably putting some garlic in it. Some seasoning on it, yeah. I think it's amazing, people. Yeah, there's some Filipino dishes. I forget what they're called. Yeah, that's what it's deep fried. It's very good. I don't know. What do you call it? Comfort food? Yes. This one here. Okay, remember what's the area to the left of that value? Remember, always think complement. What's the complement of 5%? 95. What's the decimal representation? Second distribution, inverse what? Norm. So it's going to now be, the area is going to be what? 95, right? 77 point what? 5. And then what's the standard deviation again? Was it 12.8? Let me double check. Yes. Yes. Because this is area to the left. And it looks like it's still going to be what? 99, again, to the nearest whole number. Well, the total is 100. All of the bell is 100. So if you have 5%, the complement is 95. If it's now 10%, the complement is 90. If it's 1%, the complement is 99%. Think of money. $1 and then 5 cents and $1, the complement, right? I always think of money. Well, below the default, if you say below, you're going to do area to the left. The fancy dancy and the default are the same in that case. And we'll see it. We'll see that in an example. So for this one here, 1%, remember? Let's go to the regular. Second distribution, inverse norm. It's now going to be 1%. Paste it. This is now going to be what number? 107. $107. So what's the complement now of 1%? What's that going to be? It's 99%. 0.9 what? 9. No, just showing you because, like I said, some people have the default. And like if I show you now here, you go, okay, how do you do that? Second inverse norm, point what? 99 now. That's the default. It's always, the default is always area to the left. So that should be 100 and what again? 107. Same exact answer. Default. Bottom what again? This is the bottom 10%. So this is now what kind of tail here? That's a left tail question. Okay? Because it's bottom 10%, left tail. So how do you write 10%? This is going to be point what? Yeah, 0.10. Now notice, isn't that area to the left? So that would be the default, right? And, yep. So if you had the good calculator, or is it not the good, the fancy dancy, right? The one that's more options, inverse norm, 0.10, and you want it to be a left tail, enter, you what? Paste. What do you get now? 61. There you go. Now you said, what about the default? Well, shouldn't it be the exact same thing? You guys know what I'm saying? Isn't that area to the left the default? Yes. Maybe you say you don't believe me. Second distribution, inverse norm. Point what? 10. Paste that. Let's do, yeah. Isn't that 61? Still 61. Bottom 5%. This should be what now? Isn't this 5%? 77.5 in the middle. Okay. And how do you write 5%? 0.05. Okay. So notice this is a left tail. Bottom is to the left. If it's bottom, it's left tail. If it's top, right tail. Very simple. So this is now 5%. So even the default, we'll try the default first. Remember, you put 0.05. It's the same mean and standard deviation. Paste it. This is what? This is 56, ladies and gentlemen. But you say, no, I have the fancy dancy calculator. So 0.05 paste it. What does that give you? I'm sorry. We screwed up. Second distribution. Okay, inverse norm. It's area to the left, not the right. See, we screwed up. It's a left tail. Okay. Should be 56. And sure enough, right, it was 56. So anyway. So if you are 56, if you're 56 or less, by the way, anybody that lives in Hawaii and your lifespan is no more than 56, you're in the bottom 5% of lifespans. That's the age, 56 years. So some of your homework questions are just like that. Is that right? Can I ask you guys a few questions here? See if you guys can do these. 5. What is Q1 and Q3? Give you guys some time to figure those out. Previous information. Hawaiian lifespans. Okay, did you guys get these in your calculators? What's this? This is going to be the what? Bottom 25%. 25% is 0.25, okay? In the TI, that's known as what? This is a left tail. Is that true? Now, this other one, you say, what's the other one? This is what? Top 25%. This will be 0.25. And the top, this is a what kind of tail now? That's a right tail in the TI calculator. Okay. Let's go to the calculator now. Second distribution, inverse norm. I'm going to do the bottom 25. Let's go back. That should be 25. That's left. Is that true? What do you get? What is this? What number is this? 69. Q1 is what? 69. First quartile. Let's find Q3 now. You go, well, what do you get? What do you do for Q3? Okay. Second distribution, inverse norm, and that's still 25%, but what do I do now? I go to the what? I go to the right. So that's going to be what number now? To the nearest whole number. 86. Q3 equals what? 86. There you go. So what if you said for Q3, Mr. Judge, what about the default for Q3? What do I use? I'm going to change this to default. You guys remember? It didn't change. Default. Anybody know what I use? Yeah, it's going to be the complement of what for the default? Do you guys know? Complement of 25, you're right. And you can see this is going to be 25, 25, 25 will give you what? 75. Outstanding. 0.75. So in the default, we got to change that. Second distribution, inverse norm, 0.75. And what is that number? That's what? 86. And there you go, ladies and gentlemen. So if we looked at that, the browser now, you go, this is all the way back with what? Where's this thing at? And, like I said, this might be the time to give you guys more homework questions because some people may feel they need it. This is the worksheet, right? So some of you guys might have looking at this, you go, oh, there's Q3. See, starting at question 11, what do they ask? First quartile, Q1. What's question 12? Q3. What's question 13? Q1. What's question 14? That's second decile. What's that? D2. Question 15 is Q3. And what about question 16? D6. And then you say, but Mr. Judge, if I get stuck, you have a what? A TI tutor. Okay? And more than that, You got a tutor where? At the lab. And you even have what? Online tutoring. Did we talk about that? You guys have more resources than human existence has ever known. More resources, more help. No? You guys don't have more? Remember, if you don't use them, you're going to what? You're going to lose them. This school will take them. Trust me, they're looking to take things away because they got other things they got to pay for that are their priorities. It isn't necessarily what? It's not necessarily what you think, ladies and gentlemen. Trust me on that. There's a lot of money that what? It's going somewhere else than where it should go. I mean, it's like, really? I mean, isn't that sad, ladies and gentlemen? That's pretty sad, but, you know, just try to have a good attitude. And that's the best you can do, I guess. Is that right? All right, you guys. Look at that homework. I think I might give you some bookwork there too, since some people might request that and say I need a little more practice. And I have some bookwork. We do have a book, and maybe that would be helpful for some. But I'll grade your test 3, give it back to you guys tomorrow, and then you'll be up to date. Okay, so take care and stay safe. We'll see you guys later.